Hello, everybody. This time I would like to talk about my research on the solar system formation, quantum radiation, and natural disaster. What motivates me into conducting this research is mainly the natural disaster. I would like to be able to predict when the natural disaster will occur in the near future, as well as understand how it occurred in the past, and that links to the relationship between its occurrence and space weather surrounding the Earth, as well as a lot of things that's going on in the solar system. And that leads me to developing the understanding of how solar system will form, how solar activity arise, and how that's ultimately linked to the Earth in terms of Earth changes. So, in order to understand how everything works, I would like to propose a simple concept, because through simple concept, we can understand things in a way that we can implement it in our daily life. And in order to be simple, it has to be simple to observe. That means everyone can do it by themselves using your own perceptions. And of course, in today's world, we also have additional senses through satellite images and all the instruments that human has developed. And of course, we will use that as a secondary sense. In terms of solar activities, I would consider mainly the sunspot, which is the simplest thing that human can observe through the simplest instruments, such as a telescope and projecting the light into a paper or something like that. And of course, today's we also have other instruments to detect coronal mass ejections, solar winds, X-ray flares, coronal holes, and all kinds of things that actually be useful in terms of tying all the connections together. And of course, if it's simple to observe, it has to be simple to reproduce and verify, and it doesn't cost you like billions of dollars to verify it. It's something that you can prove within a short amount of time if you have the right perception in how to observe things. And last but not least, what you see is what you get. We actually provide you direct evidence from space as well as on Earth. The way we observe Earth's phenomenon is very simple, just like how the wind blows. We sense the wind, tornadoes, formations. We can observe that. People can feel the earthquakes, the vibrations, or even volcanic eruptions. And of course, it linked to physical experiments and personal experience. So, in order to understand everything in a simple way, we need help from the conclusion from great philosophers of this world that is living today, as well as those in the past thousands of years ago. And these people have observed the world, the solar system, and of course this universe in the most profound way, and have come to a conclusion that never change with time. And the first one is dependent origination, which means that all things arise independent upon multiple causes and conditions. Just like the way human body has activities, that these activity cannot arise from ourselves alone without air, food, and water that's supplying us from the surrounding. We cannot have such activities. And if those surrounding conditions is removed, then the body will pretty much die in a few minutes. For example, if we cannot we cannot live without air or water or food. Second is everything in this world, everything we observe, we can perceive in duality at least. What it means is, for example, if we observe a coin, we also know that it has two sides, not one side. When we perceive some object of interest, we have to be aware that there might be some other possibility or assumption that actually works in terms of solving the same problem. Of course, see things the way it is to see that everything comes and go. It's always in the subject to change. For example, the assumption that electric exists in this universe, of course, in the state of changing. The assumption that this universe is electrically neutral is also changing. It's temporary. And of course, everything is a conditioned process. So it does not arise by its own. That means there's no true essence in it. Or this characteristic is called non-self. So now we go to the main topic of quantum vibration. The word quantum in definition means the minimum amount of any physical entity involved in an interaction. So in this presentation, we want to perceive something in duality, so that is pretty much considered the simplest state of something involved in an interaction already. For example, if we want to study charge particles, we can perceive that the charge can be positive and negative. If we want to study electricity, we have to be aware that there are both electromagnetics and electrostatic properties of such things. If we want to study some object in terms of waveforms, we have to be aware that there are two types of wave exist. One is transverse wave, the other is longitude wave. If we want to study the dynamic of an element or matter, you can perceive if something is contracting or expanding. And of course, if you want to look at some organized system become order, we also have to look at the way it becomes chaos. These are just example of the way we can study something, and all this exists in all state of matter. These matters are plasma, gas, liquid, and solid. And all these properties exist in vacuum or the surrounding environments, which subject to change at all time. So if we want to study the universe, Nikola Tesla has suggested that we should think in terms of energy, frequency, and vibration. So these are the secrets of the universe that he suggests. So first we want to study the energy part. I would like to emphasize the study in this case to electric energy. So we go to the first experiment of plasma fusion. And of course, the way we can create fusion using electricity is through electrostatic device. In this case, we have a chamber. In the glass chamber, we supply a 9 kilovolts high voltage power supply to the electrode at the center. And of course, we have ground on the end of this tube. And here's the experiment, what it looked like. So by pumping air out using a vacuum pump through one of the hoses on one side, by supplying high voltage, you start to see how plasma become initiated and form a sphere at the center of the tube. you can see some filaments coming out from that plasma, and it changed quite rapid pace. And if we observe the sun the same way, we see that they're exact same thing that's happened at the sun. The top right graph show the stereo images of the sun in large angles. The circle, small white circle, will represent the sun size. You see that the same way that's happening. So we see a plume of plasma pointing out, just like the one we see from this experiment. So if you continue to watch this experiment a little longer, we can observe that if the condition of the plasma in the vacuum chamber change, in this case right now it's uniformly glow. So the vacuum, we have low pressure of ionized gas, but once this condition change, you start to observe something happen to the sphere at the center. Just please watch carefully. So right now, when the vacuum pressure change, you start to see more activities going on in the center of the plasma sphere, as well as a glow at the end of the tube. So these are two conditions that actually create some change due to the external environment that we are observing the plasma sphere. So from here we can have two major observations. So during the high vacuum pressure, we see that there's more filaments going on at the surface of the sphere and surroundings, and that's really, we can compare that to high solar activity period. So in that time, we see more electrical discharge activities in the atmosphere of this plasma. We can consider strong magnetic activities because there's more discharge, and of course what we call this is solar maximum at the sun, and during that time, of course, more discharge produce more X-ray emissions. So this is common during solar maximum, and of course this also ties to high number of sunspots. On the other hand, when the vacuum pressure is low, we see a more uniform glow of plasma, and that's compared to low solar activities. During that time, the sun is more illuminated, but there are less filaments like electrical discharge because it's more uniform glow. So that means when you have less current discharge, you have bigger magnetic activities. However, that doesn't mean that there's no activities. It actually means strong electric activities. If you follow my previous presentation about how electric works, is that the more electrics we have, the more stress we have, and that's ties to earthquakes. So this is one of the reasons why strong earthquake, large magnitude earthquake, occur during the time when there's low number of sunspots. And this is called solar minimum, and of course producing low X-ray emission on average, but some events can produce high X-ray emission during solar minimum. And we call this period as low number of sunspot, but it doesn't mean that there's no activity or it doesn't affect the earth. It's going to affect the earth in some certain way, different from the other period. Of course, if we consider this compared to an outer age of solar system, we see that it looks very similar to the sun and halo paths, and that's kind of compared to what we have in our solar system. And of course, in this case, the experiments try to visualize how the sun is a focus of cosmic electrical discharge, and that's what Ralph Jurgen has envisioned. and hopefully this kind of represent his vision, maybe some of it over here. Next we move to what Nikola Tesla has suggested, that everything requires energy, frequency, and vibration. And this will try to demonstrate how frequency, energy, and vibrations will be influence the activities of something. So in this case, we rely on Dr. Han Jenny experiments, where we put fine powder on the membranes, putting sound wave perpendicular to this membrane. So in this experiment, we put vibrations into it.
Now we should take a closer look at these movements.
So here you can see that circulation is formed through vibrations. We can see small vibration at the surface of the sphere. It looks very much like a nanoflares as well. In addition, you can see that vibration will result in spin and rotation, as well as eruptions at the surface of the sphere.
We see two regularly and continuously rotating areas at either end of a diameter.
So this is what Dr. Han Jenny has observed, and I use his video for demonstration.
Of a rotating wave motion. We can see they are rotating in an anti-clockwise direction. We now switch to a different frequency.
Now frequency switch.
The same phenomenon, but this time in a clockwise direction.
Now we can see that rotation can change by changing the frequency of vibrations.
We have the same phenomenon again in an anti-clockwise direction. Notice that this rotary movement does not affect the circulation or convection in the least.
So now we can conclude from that observation that we can divide to two behavior. One is internal. We can see that there's a circulation and convection occur when we apply vibration to a substance. And of course, this is very similar to how the sun behaves internally, that we have a meridional circulations, and that's what scientists has discovered. In addition, we observe explosion and ejection from the surface of the sphere, and that's very kind of similar to the way the sun have active regions and coronal mass ejection. Now we go to external behavior. We also notice that this sphere has a spin and rotation, and if we extend that beyond the sun surface, we know that it's very similar to the way Parker spiral works. So you have two main arms coming out and rotation. And of course, if we see other star systems such as red giant star or Scorpioris, we see about the same thing. But we start to see that the outer ring of the this star system start to merge into a ring rather than a spiral. And of course, last but not least, the behavior that we want to pay more attention to is called standing wave, which is a bigger picture from the rest. And of course, it looks like a band of orbits, just like what we have in our solar system called orbital plane. And in other star systems such as Altauri protoplanetary disk, we see the same thing. It's a band of resonance from the center of the star. And of course, this is we should be able to see this remnants of vibrations in our solar system, such as the one we shown for the early star formation. Observations. So we know that through changing of vibration frequency create various type of activities in the sphere and also outside the sphere. Such activity match with the characteristic of the sun and the solar system. An organization of matter, fusion in this case, is a result from vacuum vibration at resonant frequency. So by reinforcing the energy at one frequency, you can see that order can arise from chaos. And of course, ultimately, energy used to create and sustain the sphere alone comes from the surroundings. And that's, if we observe the sun, we saw that there's a lot of activities on the surface. We have to be aware that all this such activity cannot persist without energy supplying to it, just like the way we demonstrated in this experiment. And of course, there's two main wave patterns generated from quantum vibration. One is the spin, which is the spiral waveform, and the other is the standing wave. And this is the mode that we would like to emphasize in this talk. So we will extend this understanding into further details. So now, if we want to look at how the oscillation works, so we go into this experiment of plasma discharge tube. This is where we have same thing, we supply high voltage energy in a vacuum environment. So that's the plasma by itself typically generates ripples. And this ripple of oscillation has a standing wave characteristic as well as a longitude waveform characteristic. So that's very similar to what we described in Hale protoplanetary disk formation. So it requires some certain vibration frequency as well as electrical energy supplying to it for it to exist. So next we go into two-dimensional 2.5D simulations of vibration frequency. In this case, we use the Clanny plate, where we supply vibration to the center of the circular plate. We put particles around this plate, and we start to see how particles organize themselves around the center of the vibration. Using different frequencies. So this is very similar to the way we observe how asteroid belt exists in our solar system. And of course, if we increase the frequency to a higher rate, the vibrations start to form multiple rings and become finer in terms of orbital path, where those particles can park itself. And that's very similar to the way we see all the planets in our orbits. And that's one of the possible mechanisms that all planets stay in orbits, is because they lock through this resonant vibration. So this is a theory that is possible explanation of what we observed. Next, we want to look in the three-dimensional standing wave mode. Relies on the Argonne National Labs acoustic levitation experiment. So in this experiment, we see that the sphere can levitate due to the effects of standing wave. And as you can see, each ball does not remain static. It has some micro vibrations and it changes with the frequency. As you can see that it matches with what we observe in this solar system. So that means if the sun vibrates, we would see all planets vibrate in synchronicities. So that's kind of lead to an new understanding of how the connection between the sun and the earth will be like through resonant coupling. So in this case, we know that the sun and the earth is separated, and of course it's the third planet from the sun. And of course, if this concept works, we should see the same vibration frequency observed at the sun as well as the earth. So in this case, distance from the sun and earth is 149.6 million kilometers, and that's equal to 3.5 wavelengths in this vibration. If we assume that the wave is travel at the speed of light in vacuum is 3 times 10 to the power of 8, that frequencies turn out to be around 3 millihertz. And of course, we observe exact same thing happening to the sun through the P mode vibration or in the HALE seismic frequency that occur at the sun. Using golf instruments that measure the spectrums during the time of 19 February and 25th of March 1996. You measure the P mode, which is a longitude wave mode or acoustic oscillation, occur right around 3 millihertz, just like the way the earth and the sun are separated. And of course, in the earth, we should see the same thing. So in this band, which HALE physicists call the 5 minutes oscillation, or the band between 2 and 5 millihertz, we observe the same thing at the earth. But this has to be excited by large earthquakes to see the background vibration. So in this case, there's a paper published in 1989 and which observed the low frequency vibration that's occurring during a time when they have Great Chilean Earthquake in 1960. And this frequency is observed across the globe from different seismic monitoring stations. And of course, it peaked around 2 to 5 millihertz. And of course, this peak should exist in pretty much objects in the solar system, especially surrounding the Earth if we want to compare it closely. In this case, we look at the comet HALE-BOPP, and of course, scientists have found the same 5 minutes oscillation in solar wind of comet HALE-BOPP. And that's not only applies to the surrounding, it's applied to the coma of the comets. In this case, the vibration frequency is the same, about the same as that observed in the Earth. So it's between 2 and 5 millihertz. Of course, from this understanding, we can develop a model of resonant coupling system between the sun and the Earth. And of course, it might not represent the whole complete picture, but the main one. In this case, I relies on the invention from Nikola Tesla back in 1900. So in this case, he proposed a way to transmit electrical energy from a source to a destination. So we have two ball sphere, which will represent the sun and the earth. Of course, it's just a tiny dot in space. And Of course, the generator is applied through primary and primary winding, and of course there's a secondary windings that ties to the ball. So in this video I have constructed an experiment, and you can do this yourself through this instruction from the link. So over here we have the generator working at 3 megahertz frequency, because we cannot do 3 millihertz, everything scale about 1 billion times. 50% do these cycles, square wave waveform supplied to the primary, which is the generator part, and of course the secondary is flat spiral windings, one side connected to the other flat spiral winding, and the other side connect to the sphere, which is the receiver. And of course we have the primary side coupled to an LEDs, 6 LEDs in this case. So you can see the brightness of the LEDs. So there are 4 different ways to modulate the whole system. One is to modulate the amplitudes of the function generator. Of course, this will change the whole input. Second is to change the frequency. So here I reduce the frequency. You can see the LED light bulbs goes away, and as I increase the frequency back, it goes back, and if you increase it again, it goes away. So this demonstrates that this system is a resonant system, just like how the sun vibrates. And of course, the third way to modulate the LED outputs is to modulate the first sphere. Let's say we have different plasma density around the transmitter side of this ball. So I move the hand close to the ball. You can see how the power got modulated in the destination. Let's say you have a coronal mass ejection, you pass through it, so you got another secondary modulation in the receiver side. So now, from observation from the previous slide, we know that there are 4 major approaches to modulate Earth's electrical environment. One is to modulate the galactic generator amplitudes. So this will apply to the whole solar system. Second, to change the generator's frequency. Also applies to the whole system. And this could be, it's called global change in plasma environment. And that could be referred to 11 years solar cycle, or even more, or even less. The third way is to change plasma environments surround the local generator sphere. In this case, it's the sun. If you have celestial body passage around the sun, you can detune the capacitor, and of course causing disruption at the sun. We also know that the sun is no longer the sun by itself. It relies on external environments to change the activities. So that means all the heliocentric planetary alignments will have effects on the solar activities. So we will see coronal mass ejections occur more often during a time when there's planetary alignments. And fourth is the change in plasma environments around the local receiver sphere, which is planets. Of course, we study about wave, so there's 2 types of waveform that propagates and change the plasma environments. One is to longitude wave propagation. The second is a transverse wave. Of course, we have wave, then we have particles, so it's duality of each others. In terms of particles, we look at coronal mass ejections and solar winds, which can modulate the plasma environment. And of course, the same as the sun, Earth is subject to change due to external environments. In this case, it's planetary configuration. So geocentric planetary alignments will have effects on changes at the Earth as well. Similar thing apply for celestial body passage. So these are called local change in plasma environment. Of course, look at how the comets, when they hit the sun produces coronal mass ejection. can be explained using this model. So we consider the capacitor was detuned when there's an object approach the sun, resulting in change in resonant vibration. So now we know that all types of wave exist in solar system, not just limited to electromagnetics. Now we have both electromagnetics and electrostatic. In terms of electromagnetics, the current way we observed the activity is through magnetic field. Change in magnetic fields typically try to translate to a lot of things that's happening in the space. And of course, for electromagnetics, there's no such thing of zero magnetic field except for light wave. However, for electrostatic propagation, we have both the type of ripples that have zero magnetic field and there's still activities. Those are ion acoustic wave and plasma oscillations. So of course now if we're using the magnetic field alone to gauge for intensity of fluctuation, we may miss some of the phenomenon that is occurring in other modes. So now we go to the case study of quantum vibration in the solar system related to natural disaster. So we apply understanding from what I previously talked about to a real world situation. So this is a real application of the theory. So in this case, we look at a short-term case study between April 20 to 25th, 2015. If everyone are aware, we have Nepal earthquakes magnitude 7.8 on April 25th. And of course, during that time, there must be some special thing happen in space. And of course, that goes to the sunspot. So between April 20 to 23, the sun has the highest number of sunspots in 10 weeks. And of course, the long-term precursor will occur, and we have observed about extremely hot weather around the equator of the Earth. So people who live near the equator, we observe that the weather is quite hot, 24 to 48 hours before earthquakes. And of course, locally in Nepal, those people observed extremely cold and windy weather near the earthquake epicenter before the earthquake occurred. And for short-term precursor, we observed strong CMEs on April 20th, 21st, and 23rd, as well as large solar flares M4 on April 21st, 2015. And of course, this exists with low level of geomagnetic storm. As I mentioned before, this mode of longitude wave does not necessarily translate to fluctuation of magnetic field. So it also exists in a time where there is a planetary alignment between Earth, Mercury, and Mars around May 20. So from there we can map everything into the timelines. We zoom into the situation where we have peak sunspots around April 22nd. And of course, we have solar flares occur, which is non-Earth directed CMEs. Of course, this is a different type of mode of propagation that we should observe at the Earth. We got solar flare M4 on the 21st. That follows by the foreshock earthquake in Nepal, magnitude 5.1, which is highly unusual. Then we have large volcanic eruption in Chile in several years. And of course, that happened around the peak of sunspot. It follows by another non-direct on Earth's directed CMEs with M class 1 on April 23rd. And of course, about 3 days later, we observed the main shock in Nepal, magnitude of 7.8, and of course an aftershock. As you can see that the spacing between two main events is about 3 days, which highly linked to the speed of the solar wind travel from the sun to the earth. The next case study is between March 7 and 11, 2011. We observed that during that time we have peak number of sunspots. But this sunspot is very special. It increased rapidly over a few days and exceed the previous peak of sunspot by more than a factor of 2. So this is highly significant event to observe in space. And of course, the peak sunspot come with large coronal mass ejection as well. It's non-Earth directed, but it has some Earth components. And of course, these eruptions come with the presence of the coronal hole. As you can see that the coronal hole start to form over a large area on the south side facing the Earth. So during this time, we can map all the timeline together, and we see that the global foreshock in this case occur around March 8th. We have the Japan foreshocks as a precursor, and about 3 days afterward we see the main shock of earthquake of 9 magnitudes. And of course, between March 7 to March 10, we observe ionospheric heating effects near the earthquake in Japan as well. So they all happen in synchronicities, but they have happened with the cause, and of course there are signs outside the Earth that we can observe. Next is the case study during a time in the solar minimum. If the maximum have some significant effects, the minimum will have the same kind of effects. Of course, during the solar minimum, we know that it's an electrical period. So where it's highly potential, the atmosphere is less discharged, so it's more stress can build up underground. So that would be a potential cause of earthquake. And of course, there are studies that make an earthquake occur more frequent when sun has fewer sunspots. So that ties really well to this theory. So in this case, we observed that the sunspot number between October and January 2005, we see a local minimum, so it's 10 weeks local minimum, occur between December 17 to December 27, 2004. We have a CME, which is a coronal mass ejection precursor, occur on the 23rd, which is a significant one, especially during solar minimum. And of course, if we map the timelines and look at the coronal hole, we see the same thing. We see expansion of coronal holes right facing the Earth. And of course, in this timeline, we zoom in, we see the precursor or the foreshock occur on the 23rd. And of course, about 2.5 days later, we see the main earthquake. So the pattern has been repeated for all large earthquakes in the past, and of course, this 2.5 days represents the speed of solar wind or wave propagation in plasma, in addition to simultaneous response that's occurring between the sun and the earth through vacuum propagation. So there's an overview of the sunspot connection with large earthquakes. In this case, I would like you to pay attention to the time between April 2015 to June 2015. We see that large earthquakes, magnitude greater than 7.3, occur during a time when there's a convergence of sunspots number. And of course, this doesn't happen all the time because there's a dependent term associated with the way the Earth interact with the atmosphere and the plate. So during the time when there's a high humidity, lots of water content in the atmosphere, lots of energy is stored in the atmosphere rather than underneath the ground. So during that time, when the sunspot is peaked or minimum, if the water content is high, then we typically do not see large earthquakes, especially during the time when the solar maximum. So that can break, this correlation can break because the condition of the earth change. We just don't look at one direct conditions, so there are multiple causes. So in conclusion, the theory of quantum vibration and its relation to solar system formation were presented. The theory helped explain various characteristics of the sun and its surrounding space. Because there's evidence of quantum vibration can be found in helioseismic and geoseismic activities, as well as comet interaction with solar winds. Of course, theory suggests existence of longitude wave in both vacuum and plasma. So longitude wave exists in vacuum, that means it's highly possible that ether do exist in space. And of course, the earthquake, especially the large ones, are the direct evidence of longitude wave vibration in space. So this kind of coupling is a confirmation of how the vacuum vacuum environments can support wave propagation in longitude wave. So longitude power couplings, strong earthquake can occur without the presence of geomagnetic storm, and these findings are highly agreeable with a lot of researchers that found some connection with geomagnetic storm with earthquake, but not necessary, and that could explain why. Finally, I would like to thank the Thunderbolt Project's Mitch Pastoral's National Disaster Report, who actually motivates me to work on this at the first place. Stan Ayo, who have done a lot of experiments with vibrations and resonance. Similar thing for Nassim Haramein. Musa Abdullahi, he provided theoretical proof of longitude wave in space using mathematical calculations. I'd like to thank Ben Davidson, who have been providing us all the news, research, and all the solar activities report, as well as some predictions, and that's spread throughout the world and have millions of viewers. I also would like to thank several YouTubers for sharing wonderful experiments, and actually those who do predictions, such as earthquake predictions, volcano predictions, because through predictions we can understand things more. When we make mistakes, we can correct for mistakes later, but without trying at all, we don't know what's going on at all. So thank you very much, all these people, and thank you very much everyone for listening.